find the remainder when this number is divided by 50. Now, as you can see that these numbers which are given, they are in GP, right? We have 1, then we have 3 square, and in this manner, we have up to 3 raised to 2021. So first, let us calculate the sum of these in terms of GP using this standard formula, that in GP, sum of n terms is a into r raised to n minus 1, where a is the first term and r is the common ratio, and this divided by r minus 1. So first let us find this number, and then we'll see that how to figure out the remainder when this number is divided by 50. So here if I calculate sum of all these, let us say that number is n. So this n will be a is 1 and then r is 3. So we'll get also in denominator we'll get r minus 1. So r minus 1 means common ratio is 3. So we'll get 3 minus 1, that is 2. And 3 raised to number of terms. Now first term is 3 raised to 0, last term is 3 raised to 2021. So starting from 0 up to 2021, the total number of term will be 2022. So basically this is the term, right? N is 1 by 2 and this is the number 1 by 2, this multiplied by 3 raised to 2022 minus 1. And now we are dividing this number by 50. So we have to find the remainder. Now see here what we can do is uh, we can, instead of trying to find remainder when the number is divided by 50, let us try to write this number as multiple of 100, right? And then from there we can see that what should be the remainder if we divide by 50, because 100 will be a perfect square and we can very easily create multiples of 100 here, right? You can write this number n as half of, and then if I have to create multiple of 100, then this number we can write as 3 square raised to something, right? And 3 square will get 9. 9 we can write as 10 minus 1, right? So 3 raised to 2022, this we can write as 3 square raised to 1011. 3 square is 9, which is minus 1 plus 10. So minus 1 plus 10, this raised to 1011 minus 1, right? And now let us apply binomial theorem on this one. So if I apply binomial theorem, we'll get minus 1. The next term will be 1011 C1 and this multiplied by 10. Right, the first term raised to odd power, so we'll get negative sign. Second term will be positive. And after that, the third term will contain 10 square. 10 square means we have multiple of 100. Right, so after that, all the other terms we can write as multiple of 100. Right, so basically this is the number that we are getting. If I further simplify this one, we'll get 10110 and then plus multiple of 100 minus 2, right? When we are expanding in terms of exponent of increasing powers of 10, so only the first two term they are not multiple of 100. After that, the third term will be 10 square, fourth term will be 10 cube, and so on. So all of those numbers, they are multiple of 100. And because we have 1 by 2 outside, so when we can easily figure out what should be the remainder when we are dividing by 50. So now we can write this number as 1 by 2. And from here also, if you want, you can separate multiples of 100. That means this number you can write as 10,000 plus 110. Right? In fact, we can write this as 10100 and 10 minus 2, that will be 8 plus multiples of 100. And now this is also multiple of 100. So we can combine these two. And finally, the number is of this form, right? If you divide by 2, so 8 by 2, that will become 4. And these two numbers you can again combine, right? You can take 100 common and then you have lambda plus 101. Lambda is just some positive integer, right? Lambda is any positive integer here, some natural number. So lambda plus 101, that will be another natural number. So basically these two terms, they are multiple of 100, and when you divide by 2 you will get multiple of 50. So this becomes 50 lambda, and 4 by 8 by 2, that will be 4. So finally the number is of this form, multiple of 50 plus 4. And now if you divide this number by 50, clearly you can see that remainder will be 4. So this was a very interesting problem where first we had to identify the number, using this formula of sum of n terms of ZP. So A into R raised to n minus 1 by R minus 1. And now because we are dividing by 50, so we have tried to create multiples of 100, right? So for that, 3 raised to 2022, this we can write as 3 square raised to 1011. And now expand it using binomial theorem. And we'll write the first two terms, right? First term is not multiple of 100. Second term is also not multiple of 100. After that, all the other terms, they are multiple of 100 because they will contain 10 square, 10 cube, and so on. And now this number also you can simplify. You can separate 10110 from there. So finally you are left with 10 minus 2, which is 8. 8 by 2, 4. And rest of the numbers, they were multiple of 100. But when divided by 2, they became multiple of 50. So the number was multiple of 50 plus 4. When you divide by 50, the remainder will be 4. And that is the correct answer for this problem.